Hello guys, and welcome to my YouTube channel. In this video tutorial we are going to talk about Arduino programming for absolute beginners. If you're a beginner in programming Arduino, this video is definitely for you, because in this video we are going to cover everything you need in order to program an Arduino board. So yeah, let's get right into it. The first thing you need to do is to install the Arduino IDE. If you have not done that, you can go to any browser and you simply type Arduino and search. You're going to download the Arduino software. It's a free software, or you go to www.arduino.cc/en/software. I'm going to put this link in the video description, so you can download any version which is compatible with your system. So when that's done, when you install, this is what you have. This is the interface that you have. And in order to follow up with this video, you will need to connect an Arduino board to your computer. And when you have done that, you go to tools. I have connected the Arduino Uno, so I'm going to select Arduino Uno. If you have a different Arduino board connected to your computer, you select that. So I am selecting Arduino Uno. Then you go to tools again, and you're going to select the serial port to which your Arduino is connected. So mine is COM3 that I've already selected. So when that's done, you have the default code of Arduino, which is the void setup and the void loop functions. And the void setup means that if you put any code here, it's going to execute one time, while in the void loop it's going to execute repeatedly or many times as it is described in the comments. This is the serial monitor, and to have access to the serial monitor, you simply press on this icon and you will have access to the serial monitor, and we are going to use it to output our data in order to see the behavior. So let's jump into the programming. The first thing I want to talk about is how to write comments. Comments are very important, and if you want to write a comment, you simply write 2 slashes and you write your comment. Like this is a comment. This comment is not going to be executed by the microcontroller. The next thing you will need to know is to use the serial communication. And in order to use the serial communication, the first thing you need to initialize it, and you initialize by typing serial.begin. And I'm going to put the baud rate, which is 9600. This baud rate is the number of bits which is sent per second during the communication with the Arduino and the computer. So when I have done this, I can simply send this to the microcontroller, and it's going to ask me to save. I can just save it, or you can navigate and save it. So it has sent already to the microcontroller. And when we have initialized the communication, we can print anything on the serial monitor by simply writing serial.print. And let me say 30, for example. So if I send this to the microcontroller, it's going to print 30. Now let me take this and let me remove this here and put it in the loop, and let's see what's going to happen. Yeah, as you can see, it is printing 30 along a straight line, and since it is in the void loop, it's printing repeatedly. So now in order to print on the line, to go to the next line, you simply add ln to this. The next thing we are going to talk about is how statements are written. Like as you can see, every statement should end with a semicolon. So if I write anything like serial.print, I should end it with a semicolon, because if there's no semicolon, it's going to say there's an error in the program. The next thing I want to introduce here is strings. So a string is simply a group of characters that can be outputted directly or used directly. For example, I can see serial.print, and let me say, and strings generally are put into quotes. So this is a string. This is a string, and if I load this, you see that the string is being printed on the communication board, right? Exactly, this is a string. So now let's talk about variables. Variables are basically like containers in which you can keep things, right? Let me define a variable, for example, like int my variable, and I'm going to put in that, like, let me say 90, for example. So what this basically means is I am defining a variable that I'm going to call it my variable, and it is an integer. The int here means that it should be an integer, so I should keep an integer here. An integer is simply a whole number. So when that's it, I can say serial dot print ln. So it's good that you always use print ln. So I say print here my variable. When I output that, serial dot begin, you see that it outputs 90. Variables can be of different data types, right? And I can also have a data type of, for example, float. And float are generally variables that take decimal points. So here I can have 90.5, for example. Now I'll need to serial dot print ln my variable. That's it. It prints the decimal, and this variable I can also call it to be a letter, like a, for example. It must not be a statement. And let's see what's going to happen. Yeah, it gives the same thing. So that's pretty much it. Talking about variables, there's what we call local variables and global variables. Local variables are variables which are defined within functions, and since they are defined within functions, they cannot be accessed by other functions. Like, for example, if I have declared float a here, if I have declared the variable a in the void setup, I cannot call it in the void loop function. If I launch this, let's see what's going to happen. You see that it gives an error because it says here that a was not declared in this scope, right? Because a is a local variable which is defined locally in the void setup, right? So in order to fix this, I can define the variable a as a global variable, and to do that I remove it and I put it right up here. Now it is a global variable. It means it can be accessed by any function, the void setup function or the void loop function, any of them. You see that it's now accessible to the void loop function. Yeah, so that's it. Let me clear this. Now we are going to talk about data types. So data types are basically the types of data that we can store, right? Like, for example, I set like int a, I define the variable which is of type int, and I put a whole number there, being it positive or negative, like -12, for example, right? And if I output, I say serial dot print a, it's going to print -12. In Arduino, the int correspond to 2 bytes of data, and it can keep values up to -32,768 to +32,767, right? The next data type that we talk about was the float. It can be used to store decimal points, right? Is the float. So I define and I directly assign 12.5 right there. So I can simply say serial dot print ln. That's it, 12.50. And float in Arduino has 4 bytes, so it's 4 bytes long. And we also have double. Double is also used. We have double, like, let me say double C. So what I want to talk about here is that I can also define a variable and not assign a value directly to it. So I've defined the C, double C, then later on I can assign here into C. I simply assign, like, let me say 40.25. So double is also used to keep decimal points. I can copy this, serial.print and print C. See how it has printed C, 40.25, right? So let me clear this. The next data type we are going to talk about is short. It can be used to store integers, but it has a smaller memory space than the int, but it depends on the compiler. The next data type we are going to talk about is long, and this long is a data type which is used. I can say long a equals like 500, for example, and serial, or let me say a, and let's see, it has 4 bytes of data, which means it can store integers with a greater range, right? And the next thing is also unsigned long. Let me unsigned long. What you have to note is that the long stores positive and negative integers, but the unsigned long stores only positive integers because it's not signed. Therefore, it can store up to twice what the long can store. So that's it. Unsigned long b, for example. So I'm going to clear the next data type we are going to talk about is the bool. So the bool data type, it simply takes true or false, right? So I can say a is true, for example, or I can say simply 1. So it's either true or false, 1 or 0. Yeah, it outputs a 1 because it's true. So I'm going to change this and put 90, and it's still going to output 1 because bool is 1 or 0, true or false. So it outputs a 1 when it's true, and it outputs a 0 when it's false. So whatsoever the value that you have here, if it's different from 0, it outputs a 1. Bool is going to output the 1, and if it's 0, it's going to output a 0. So let me clear this. Right now we are going to talk about operators. You have different operators. You have plus, you have minus operator, you have the multiplication, which is the star, we have the division operator, we have the plus plus, which is an incrementation, and we have minus minus, which is a decrementation. So let's see how to use that. Let me say, for example, I define an integer called a, and I'm going to assign it a value of 4. Then I define an integer b, and I'm going to assign the value of 5. Right, so I can define an integer c, in which I am going to say to assign the value of a plus b, right? And I'm going to serial.print C, and serial.print C is simply the sum of that, because C is the sum of A and B. So I'm going to take this off, and I'm going to put minus, and we have a negative 1 because 4 minus 5 is negative 1. So I'm going to remove this and simply put multiplication, and we have 20. Right now I'm going to put division, so I'm going to take this to be 20, for example, and this to be 5. So 20 divided by 5. I'm doing that because I'm changing the values, because we have C, which is an int. If I want to have a decimal point, I will need to change this to float, because 4 divided by 5 will give us a float. So I'll need to change to float, or I can still change it in such a way that there will be no remainder. Division. Yeah, and we also have the symbol, the modulo symbol, which is percentage. So I'm going to say a modulo b. So what this does is that it divides a by b, and it's going to store the remainder. So now 20 divided by 5 is 4, and there's no remainder. So we are going to expect a 0 on the serial communication. That's it, we have the 0. So let me clear this. The next thing we are going to talk about is the if statement.
Right.
And the if statement is very simple. For that, I'm going to define like an integer a equals to 12, and integer b equals 13. Then I'm going to say if, and this is the syntax, I'm going to say like if a is greater than b, then I'm going to put my curly braces right here. I'm going to say here serial.print and I'm going to print a string here. A is greater than B. Yeah. So as you can see, we have nothing on the screen because this condition is not satisfied. A is 12 and B is 13. If A is greater than B, this is what we are going to print. But in this case, A is not greater than B, so it does nothing, right? But now the next thing we can do is that we can say else. We can say else. We can print A is not greater than B. Yeah, as you can see now, it has printed A is not greater than B. Now we are going to talk about the else if statement. The else if statement. Remove this. Let me say we have A equals 12 and B equals 13 now. If A is greater than B, we write A is greater than B. Now we are going to test another situation. We are going to say else if A is equal to B. So the equal to sign, we use it twice, is two equal to sign, because one equals means to assign. So if we want to check if A is equal to B, we are going to use the two equal to sign. So I'm going to do this. If A is equal to B, we are going to say, I open my braces, serial.println. On a new line, I'm going to print the string A is equal to B. Yeah, that's it. So to test that, I'm going to put A to be 13, and I'm going to say again, I can still write an else if here, but I'm going to simply say else. So it depends on the number of conditions that you have. You can have as many conditions as possible, right? So I'm simply going to put here else B serial.print on a new line, serial.println A is less than B. So yeah, A is equal to B, because A is equal to B. A is 13 and B is 13, therefore they are equal, right? So in this if condition, let me clear this for now. In this if condition, there is also greater than or equal to. We can say greater than or equal to. If A is greater than or equal to B, we can write a piece of code that will be executed. So this is how we write greater than or equal to. We can also say less than or equal to. If A is less than or equal to B, that's the piece of code we can execute. And we can also say if A is not equal to B. So if they are different, we can execute a code and say, like, for example, serial.print on a new line, A is not equal to B. So I'm going to put different values, right? It says A is not equal to B, which is consistent because A is not actually equal to B. So I'm going to clear this. Now we are going to talk about the switch statement. So the switch, it works a little bit like the if statement, right? So how does it work? I can define, let me say, for example, I can say int A equals 5, for example. Then I can use a switch, and this is the syntax. I say switch, and I put the expression, and the expression here is A, and I open the braces. Now I'm going to say case 1 column. I'm going to write here serial.println A is equal to 1, or A is equal to 1. So I'm going to copy this, and after that, this is optional. If I like, I can use break here. I can break and I can copy this piece of code. So I'm going to explain what all of this means. I copy this piece of code, I paste. So this is it, I paste, and I'm going to change this to 2, for example, and 3. right? So let me launch this piece of code. As you can see, it says a is equal to 5. So what does this mean? So this switch a is simply the value or the contents of a, right? So it's saying that in the case a is 1, this is what is going to be executed, right? And this break is simply to break this in order to start a new iteration, right? So if in the case a equals 2, because we are talking about the switch here, and we are talking about switch of a. So if a equals 2, this is what is going to be executed, and so on and so forth. So this is it when we reach here, when it's 5, because into a we have 5. Therefore, when it reaches 5, what happens is that it prints a equals. In these iterations, we can also add a default value, and this is going to be executed when none of the above is correct. Like, let me say, for example, I have a to be 10, right? In a is not, it's going to test 1 2 3 4 5 and 6. It's not going to have an answer, right? So I'm going to say here default serial.print a is not among the suggested values. Yeah, so let's launch it. Yeah, basically simple. A is not among the suggested value because the value of a is 10 and we have tested this. Yeah, so I'm going to clear this right now. Okay, so now we are going to talk about the while loop. And the while loop, how does it function? I'm going to give you the syntax of the while loop. Let's say, for example, we define an integer int I equals 0, and I'm going to say while I have here I less than 5, for example. Then I open the braces to write the piece of code that's going to be executed when this condition will be satisfied. So we can say while I less than 5, we can simply output the value of I, and we have serial.print on a new line. We output the value of I. Then I'm going to say here I plus plus. Basically, what this means is we have declared a variable I and we have assigned a value of 0 to it, and now we say while I is less than 5, so as it's going to be 0, it's going to be less than 5. This is the piece of code that's going to be executed. So we are going to print I, and then we are going to increment I. So I is 0 in the first case, and you print I and then you increment I to 1, and that loop is going to take place until the condition I less than 5 is not going to be true. So let's load that. As you can see, we have the results from 0 to 4. So that's the syntax of the while loop, and I'm going to clean this. I'm also going to talk about the while loop in order to make infinite loops. So I can just say here while 1, and while 1 I can print. So while 1 I print I. While 1 is simply used in order to make infinite loops. As you can see, it's printing I infinitely. So that's it. Let me clear this off. And I'm also going to talk about the do while loop. So the do while loop functions almost exactly like the while loop, but in this case we first of all execute a piece of code before we check a condition, right? So the syntax is simply do, and you write the piece of code that you're going to execute. Here I can say here, for example, serial.print ln I, and after that I increment. Then I put the condition here while, for example, I is less than 5. So basically it does almost the same thing. Yeah, as you can see, it has printed from 0 to 4, meaning it has executed while I is less than 5. And when I is now 5, it's not going to run this do again. This is all about the while loop. So I'm going to clean this, move to the for loop. So for loop. So now basically how the for loop is being used. So I'm going to give an example. I can say for. So generally you say for, and you have generally 3 statements. So you have statement 1, then semicolon, you have statement 2, you have statement 2 semicolon, and you have statement 3, right? That's it. and after the statement 3 you don't have a semicolon, and after that you simply write the code that's going to be executed right here. So let's have an example. Like, I'm going to say, for example, I'm going to say for int I, for example, equals 0. So it's not a must for me to define the integer I in this. I can define it outside, and I simply write I here, and it's going to do pretty much the same work. So semicolon, then I'm going to say I less than 10, and I plus plus to increment, meaning adding 1 to I, right? Let me say here the value of I is space, then I'm going to say serial, and paste it here, and I'm going to remove the string right here, and I'm going to paste I. Yeah, the value of I is 0, the value of I is 1, and so on and so forth. Yeah, so that's it. It starts with 0, then it executes the code, and when it has finished executing the code, it adds 1. Because of this I plus plus, it adds 1 to I, which was formerly 0. I is now 1, and so on, so until it reaches 9. Because when it reaches 10, this condition is not more satisfied. When I is 10, I is not less than 10, because 10 is not less than 10. Therefore it's going to execute and stop at 9. So it's going to execute when it's going to be at 9. It's going to stop, right? So that's it for the for loop. Now there is one thing I will need to add here. I want to add the introduction of the statement continue, right? So continue. So let me say this is what we have. I can say here that if, for example, in this statement, if I, for example, is equal to 3, then I open my braces and I'm going to say continue. Yeah, basically you see there's no 3 here. So what this statement does is that if I is 3, it's going to skip this. It's not going to execute when I is 3, and it's simply going to go to the next value, which is 4. So that's it. That's pretty much it. Very simple. Let me clear this right now. The next thing we are going to talk about is boolean operators, right? We are going to talk about boolean operators. So boolean operators, they're simply the AND, the OR, and the NOT. Those are the main operators which are used for boolean algebra. So I can say, for example, int A, let me say equals 10, for example, and int B equals 0. So I'm going to say if, for example, let me say A or B, and the or is simply this stroke, it means or. So 2 of the stroke means or. So A or B. So A or B. If A or B, I'm going to say here serial dot print on the new line A or B is true, right? So A or B is true. It simply means that between A and B there is one of them which is not 0, right? So, or the 2 of them is not 0. I can still do this to be bool, and I'm going to put here true or false, or 1 or 0, but it does not matter when we're talking about bool here. When it is 10, it's considered to be 1, and so on. So when we are talking about the or here, this simply means that either A is not 0 or B is not 0. This statement will be true. But if this is 0, if A is 0 and B is 0, this condition is not going to be satisfied, meaning it's going to skip this. So let me just say here we have 10 as it was before. Let me launch this. Yeah, you see that we have here A or B is true. This statement is being executed. It is printing this simply because A or B is true. Now let's say we have 0 and 0. The result of A or B in this case is going to be 0, meaning it's not going to print that on the serial monitor. You see right now there's nothing printed on the serial monitor, and we can write an else statement here as we have just seen. We can write an else statement here and say, for example, serial dot print ln a or b is not true, or let me say a or b is gives a value of 0. Yeah, that's it. It's simply outputting that a or b gives a value of 0. Now we are going to talk about the AND loop, right? And the AND loop is simply this. We have, and so this simply means A and B. So remember, there are always two of them. The operators are always written double, because when you write only once, it means something different that we are not going to talk about right here, and it's mostly used in pointers, so we are not going to talk about that for now. So A and B, in this case A and B is simply like a product of A and B, right? So when the product is, when one of them is 0, the product is going to be 0, but if none of them is 0, the product is going to be true, right? But when one of them is 0, the product is false, meaning A and B. So that is the Boolean operator. So let me say, if A and B is true, we are going to say this, but if it's not true, we are going to say A and B gives a value of 0. But in this case, A and B is true, therefore the product A and B will be true, right? So we expect this first statement to be printed, A and B is true. But if one of them is false or is 0, for example, let's see what's going to happen. It's going to tell us that A and B gives a value of 0, right? Yeah, it gives a value of 0. Now we are not going to talk about the NOT operator because we have already talked about the NOT operator. So this is it. We are not going to talk about that. So let me clean this and add this. Now we are going to talk about functions, and functions is a topic which is very simple and straightforward as concerns to programming, and whatsoever the programming language that you're using, you cannot do without functions, right? So functions is one of the basic and the most useful tools that we use while we are programming, right? So a function, as you can see, is very simple. It's like you can see here we have two functions. We have the void setup function here, and we have the void loop function. So it's simply a piece of code which is executed, right? So and that piece of code generally has what we call a return value, and it has what we call parameters. And the return value in this case we have here is like when we are defining a function. So we define a function like, for example, void function, yeah, and there we are going to put parameters. So we have here parameters, parameter 1 for example, and a comma, and we have parameter 2, and so on. We can have as many parameters as we want. So basically this is how we define functions, and we are going to put here the braces, which mean the code that is going to be executed when the function is going to be called upon, right? So let me say this. I'm going to remove this and put here int. So this means that my function is going to return an integer, right? To return means that it's going to, after the function has been processed, it's an integer that's going to come out from that function. So that is basically it. So I'm going to remove this, and I'm going to put real parameters like int a, for example, comma b, int b. Yeah, so that is it. And as we have here, when we define the function, we define the function as an integer. So we need a return here. So we need to return a value. We need to return an integer because we said our function is an integer, right? So in this case there is no return for these two functions because it is void, right? It's void, meaning that it does not return anything. So let's take an example. We are going to take a function that we are going to call like addition, and here we are going to define in the function, we are going to say int c, right? And here we are going to say into c that we are going to put the sum of a and b. So I'm going to say addition. So this is the function that I'm calling the function addition, and I'm going to put the parameters 20 and 31, right? And we are simply going to say, to ask him to print like serial dot print ln the function addition. Right, let's see what's going to happen. So as you can see, it has simply printed 51, which is the sum of these two functions. So basically, when you call the function, right, when you call the function and you put in the parameters, what happens is that the piece of code here is executed, and what we have here is simply what was returned by the function. So the function is going to be processed, and everything we have here is going to be replaced by the value which we are returning, which in this case is c, and this c stands for the sum of a and b. So that's it for functions, and that's pretty much simple. You can call functions in other functions, like I can call a function here, for example addition. I can call the addition function here, and I input the parameters like 12 and 13. It does not matter, but I've not asked him to print it out, so it's not going to output the value of this sum. Yeah, it outputs only what we have here. So I'm going to clean this right now. Now I want to talk about a concept in function, which is function overloading. And function overloading is nothing but the use of two functions with the same name and with different parameters, right? So I can define another function here with the same name. Like, let me say I define the function to be int addition, and in the parameters of the function, I'm going to say int f, right? So I've defined this function. Let me put the braces. Let me say what is going to be done, the execution that's going to be carried out. So I'm defining another function, another variable here, int z, that I'm going to put the sum of d plus e plus f. So let me space this out. Yeah, int z d plus e plus f. So this is what we call function overloading, right? So let me space this out. We have function overloading. It simply means that we have two functions, and this is acceptable in Arduino programming and generally in C++, right? And this function overloading, you see that it has the same name, but if I want to call the function, simply when I put this first function that we first wrote had two parameters, this one had three parameters, right? So if I put here a third parameter, let's say 10, when this addition function is going to be called, it's going to call upon the function addition with three parameters, simply because I have inputted here three parameters. But if I call it with two parameters, this is the function that is going to be called, the function with two parameters. And I forgot here to return z, right? Yeah, and simply what happens is that it's printing 61, which is the sum of the three variables. So I'm going to clean this. So guys, right now we are going to talk about arrays. And arrays are simply variables that can be used to store multiple other variables, right? It's like a group in which you can put variables that are related, right? So let me take an example. I can define an array to be int, for example, numbers. And to define that, this is how you need to set it up, and equal to, you put the I'm going to say here 5, for example, which means that there should be 5 items. When you see this, there should be 5 items, so I can have 1, 2, 3, 4, and 5. So that's it, but it's not a must for you to precise the number of items. You can still write it like this. It does not cause any problem. I can go to 6 and even 7. So arrays have what we call indexes, right? So presently we have this one stands for index 0 of the array. We have index 1, index 2, index 3, index 4, and so on. So if I want to print this 3, for example, of this array, 3 is index 2 because we have 0, 1, and 2. So I can say here serial dot print. I'm going to say numbers and with the index 2. So if I print out the numbers with the index 2, yeah, I've defined the array, I've not put the semicolon. So when you output the index 2, this is what you have. It prints out a 3 because 3 belongs to the index 2. Right now, let me take another example on arrays. Let's say I have an array of characters, my array that I'm going to put in a set of letters, for example. So I'm going to put them into single quotes, and B and C, for example, right? Now let me say I want to access this index, the B. I want to access B, and we see that B is actually an index 1 of the array, my array. So I can say here serial dot print. I'm going to say here my array, and I'm going to put the index of 1 for B. So let me launch this, and you see that we have printed on our serial monitor B. So that said, now that you know the basic syntax, we are now going to program the microcontroller in such a way that it's going to make the LED to blink, right? We have an inbuilt LED on the Arduino Uno hardware, which is on pin 13, right? So I am going to define the pin 13 as an output pin, right? So for that, I'm going to say pin mode, and I'm going to say here 13 and output. So this statement basically defines the pin 13 as an output, right? So what we are going to do now is we are going to send a high voltage value and delay for some time and send a low voltage value, right? So to do that, we simply say digital write, and we are going to say 13 and high. Then after that, we are going to make a delay of 100 milliseconds. So this delay is actually a function which causes a delay. Then after that, we are going to say digital write again, pin 13 and comma low. It's going to get low, meaning that the LED is going to turn off. And after that, we are going to say again, we are going to have a delay again. So it's actually going to blink, the LED is going to blink. And notice that I have put that in the void loop, right? So therefore it's going to do that repeatedly. Here I am going to write serial dot print on a new line. We are going to print the string which says that the LED is on, and we are going to copy this and paste it here to say that the LED is off, right? And we are going to add, let me put this to be 1 second so that we are going to see it on the serial communication as it's being printed. So let me send this to the microcontroller. What's happening is that the LED is going to turn on and off, and each of the processes is going to last for 1 second, and this will turn on repeatedly and turn off repeatedly forever. So my LED presently on my hardware is turning on and off, and as you can see, it's being indicated on the serial communication. This is the end of this video. If you're new to this channel, please do not forget to subscribe in order not to miss our next videos. If you like the video, please share the video and give us a thumbs up. Thank you very much for watching.